Welcome back. We've seen how linear algebra gives AI its data structures. Now we explore the second great pillar, calculus. This isn't about memorizing formulas, it's about understanding how AI actually learns. If linear algebra provides the structure, calculus provides the engine for improvement. It is the mathematics of continuous change. The best analogy is to think of a sculptor. They start with a random block of stone, our untrained AI model. They then make thousands of tiny, precise adjustments, chipping away, until a perfect statue emerges. Calculus is the mathematical tool that tells the AI exactly where and how to chip away at its mistakes to improve. The entire learning process is driven by one goal: minimize the error. It's a three-step loop. First, the model makes a prediction. Second, we use a special loss function to calculate a number that tells us exactly how wrong that prediction was. A big number means a big error. Third, and this is where calculus comes in, we figure out how to adjust the model's internal settings, its weights, to make that error number just a little bit smaller on the next attempt. To visualize this, imagine the error of our model as a giant, hilly landscape. We call this the loss landscape. Being high up on a mountain peak means our model has a huge error. Being down in a deep valley means the error is very small. The goal of training an AI is to find the absolute lowest point in this entire landscape. The problem is, we start at a random point, and it's covered in thick fog. So, how do you find your way down a mountain in the fog? You feel the ground right where you're standing to find the slope. In calculus, this slope has a special name, the gradient or derivative. The gradient is like a magic compass. At any point on the landscape, it tells you the exact direction of the steepest ascent, which way is uphill. So, to find the valley, we just have to take a step in the exact opposite direction of the gradient. This simple, brilliant idea leads to the most important algorithm in deep learning: gradient descent. It's a simple loop. 1. Start with random model settings. 2. Use calculus to compute the gradient, which tells you the direction of uphill. 3. Take one small step in the exact opposite, downhill, direction. By repeating this process millions of times, the model automatically walks down the landscape and finds the bottom of the valley, minimizing its error. And that is the core of how AI learns. Calculus gives us a method, gradient descent, for our model to automatically and efficiently search for the best possible version of itself. It's the mathematical engine of optimization. In our next lesson, we'll look at the specific rule that makes this process possible for even the most complex neural networks, the famous chain rule.